Hello, welcome to the Erasmus plus CHAISE project Module 2, Regulation, Legal Aspects and Governance of Blockchain Systems. In this sixth and last lecture, we focus on the way regulation regarding data protection, namely GDPR for the European Union, is taken into account while designing and using blockchain systems. This lecture takes advantage of the knowledge provided in the previous lectures, such as the definition of the blockchain context from Lecture 1. We also pick regulation and governance background from Lecture 2, the organization of the blockchain ecosystem from Lecture 3, and the blockchain regulation from Lecture 4. This lecture has been prepared by Frédéric Bienier, l'Iris Lab and INSA Lyon, France. This lecture will mostly provide you some knowledge and skills related to the main GDPR requirements, the constraints related to the blockchain system, and how the blockchain can be widely used to manage and log both users' consents and the data usage operation. To sum up, you will be able to discuss the interest of blockchain technology to manage consent and data access, and you will be able also to identify consent management and data usage tracking requirements. This is based on basic knowledge regarding GDPR requirement and consent management as stated in the CHAISE project. Governing and protecting data is a major challenge to pursue safely the digital transformation. Of course, collecting data may take an important part in the development of the knowledge economy, and there are numerous applications taking advantage of data science. Specific regulations are set to ensure privacy, limiting personal data usage to fair usages so that people's privacy can be protected in both their real and virtual life. Let's now focus on this data protection challenge. According to your best knowledge, are there specific security risks related to personal data? What is a personal data, by the way? What are risks regarding personal data or regarding your own identity? What may be the consequences of a privacy attack? Who may attack your own privacy? What may be the consequences? By the way, who needs precise personal data about you, about your activity? Are some pricing related to your own personal data and behavior? Do you know about the price of your personal data? To ensure privacy protection for European citizens, the General Data Protection Regulation Protection Act has been set in 2016 by the European Union. But do you know how the main requirements of this act have been set? What has been involved by this law? More precisely, when you are designing a system, an IT system, how can you ensure that personal data are used fairly? When you use a digital system, do you pay attention on the way your personal data are used, stored, and managed? Why? How can you track the way your data are really used? Is it fair? Do you know how people and service providers manage your consents? By the way, you consent to what? Which process? Can you imagine some consequences? Do you know with who you are making some agreement to consent the usage of some of your data? All these questions and their answers are not so simple. We have think about it, we have brainstormed regarding these questions, and we may think more about them. As you can notice, describing data protection and identifying the way GDPR regulation impacts blockchain systems are not so simple. This requires first identifying key GDPR principles. I mean understanding why and how this regulation is set, understanding the data protection key principles in the blockchain context. This lecture is designed to provide the necessary knowledge to understand and discuss key GDPR principles, the way it impacts blockchain systems, and how blockchain can be used to manage key GDPR requirements, namely managing and logging consents and personal data usages. To sum up, this lecture addresses different learning objectives. First, data protection regulation context. We are going to focus on GDPR, and you will learn its basic motivations, some key concepts and the obligations and rights defined in this Data Protection Act. Second, we will study the blockchain regulation constrained by the GDPR. As an IT system, blockchains must also be compliant with GDPR requirements. Based on the key GDPR principles and on the blockchain ecosystem organization, you will learn key principles and challenges to set GDPR-compliant blockchain systems or services. Third, blockchain can be seen as a tool to support GDPR implementation. Due to its intrinsic immutability characteristics, blockchain appears as a convenient means to manage and log both consents and usages, so that both service providers and data providers can prove and check that data are fairly and actually collected, stored, and used. You will learn how consents can be stored and how smart contracts can be used to manage access control and proofs of usage. According to these learning objectives, this lecture is organized into 3 parts. First, we introduce GDPR, explaining its origin and introducing key principles so that obligations and rights can be precisely defined. Based on these GDPR key requirements, we analyze the key characteristics of blockchain systems to identify how GDPR-compliant blockchain systems can be set, pointing out remaining challenges and debates. As said previously, blockchain can also be used as a support to manage consents to track data usages. In the last part of this lecture, you will be introduced to smart contracts used to manage, log, and prove fair and authorized usages. So, let's start now with the first part, introducing GDPR. The General Data Protection Regulation Act, GDPR for short, has not been defined ex nihilo in 2016. Personal data protection has been initiated in France in 1978 by the Informatique et Liberté Act, defining which kind of information can be collected, used and stored, which information cannot be used, how to declare files storing personal data, and so on. For example, information related to religion, politics, ethnic or trade union preferences or affiliations cannot be processed nor stored without specific authorizations. Since 1995 and the publication of the European Union 95/46/CE directive, this privacy regulation has been expanded to the European Union. This European Union Personal Data Protection Regulation was designed with a quite different strategy than the market regulation strategy deployed in the USA. To sum up, USA has a strict regulation for minors, protecting them provided that they are less than 13 years old. But there's no constraints for older persons, as the Federal Trade Commission considers that services with unfair or low privacy rule will not be used by customers. This is typically the market regulation. To deal with international constraints related to the European Union 95/46/CE directive, the Federal Trade Commission has introduced the safe harbor principles and certification so that US sites respecting this European Union directive can be identified. Nevertheless, this international agreement was invalidated in 2015 as the level of protection provided by the USA is insufficient with regard to the European Union requirements. This invalidation has led to the development of the European Union United States Privacy Shield, regulating data transfer from European Union to USA. This agreement was also invalidated in 2020 as its protection level do not fit the European requirements. The European Union GDPR has been defined according to this strong privacy regulation background to fit the worldwide privacy challenge involved by the fast development of the internet-based services, the development of the data economy and big data. This regulation, used as a model by other countries, has an extraterritorial scope. It means that personal data of a European Union citizen must be protected worldwide. Personal data encompass all types of data related to a natural person: its name, address, phone number, its financial information and transactions, health record, genetics record, as well as data related to its digital life, images and video digitally stored, traces of the digital activities, and so on. The way these data are used by manual or automated processes, including business process and big data statistic processes, is regulated to ensure people privacy. To manage data protection, GDPR introduces different roles: subject, data controller, data processor, and data privacy officer. First, the subject is the physical person to whom the data are related. The subject is a natural person in charge of defining its own privacy policy. To this end, the subject must explicitly consent to the data collection, storage, and usage. This involves that the subject must be informed in a clear and synthetic way on the purpose of the potential processes, with who the data may be shared and for which purpose, the time period during which the data are stored. Nevertheless, providing informed consent does not mean that the subject is fully aware of the risks of the potential violation of its privacy. As consents are provided separately on one hand, and as the current knowledge about privacy risk or digital hygiene is often rather limited and sometimes inexistent on the other hand, we got most important privacy risks due to the subject by itself. Then, the data controller is a natural or legal person representing the entity in charge of designing, running, and controlling the processes using personal data. The data controller must be clearly identified and is accountable of the process. This is why he or she must verify and may have to prove that the process is fully compliant with the legal requirements. The data processor is the entity in charge of processing the data on behalf of the data controller. Both are different. As a consequence, it is not accountable of the process, but the data controller is. The data processor must simply ensure that security means are implemented to reduce security risks while processing or storing the data. The data protection officer, sometimes called the data privacy officer, is in charge of implementing GDPR. The data protection officer is a natural person in charge of managing globally the data security and the privacy protection. This means that the data protection officer must interact with the information system security officer to ensure that security risks are clearly evaluated and that the necessary countermeasures are deployed to mitigate risks affecting the personal data. The data protection officer is also in charge of managing globally privacy protection and usage control, constraining data controllers while designing and managing processes. As said previously, GDPR is inspired by works leading to previous regulations such as the European Union Directive 95/46/CE and international agreements between European Union and the USA. Protecting privacy involves a fair, lawful, transparent data processing. This means that data controllers are accountable of this requirement, involving a clear identification of the targeted usage and data minimization. Data minimization means that only the necessary personal data must be collected and stored for a given purpose. Although data archiving is allowed, other extra usages are forbidden. Other usages means usages which were not identified or not necessary for the process. This purpose limitation involves that all potential usages must be mentioned and justified while the consent is obtained. Regarding the data archiving, unnecessary data must be deleted and only a time-limited storage is allowed, except for data used for scientific or public interest usages. Respecting these constraints is not enough to be compliant with the key principle of fair, lawful and transparent data processing. This means that data controllers and data protection officers must ensure that the data collection and processes fit legal constraints. It means that very sensitive data, such as religion, ethnicity, trade union preferences, must not be collected nor processed without a legal derogation. To ensure data accuracy, subjects are allowed to get access to their own data and to update them. As valuable resources and to increase privacy, a particular attention must be paid on data confidentiality and data integrity. These GDPR key principles lead to different obligations for data collectors. First of all, the fair data protection involves that the data controller must get an informed consent from the person to which data are related to. This means that this consent cannot be summed up as "we are collecting data for due purpose, click to continue." No. Subjects must be able to tune their privacy requirements according to the information on the usage purposes. This information must be provided in a synthetic and understandable way, describing both potential usages, purposes, and who may use the data according to these different purposes. In fact, you cannot write your consent or ask for consent with a ×4 document. People must read it. People must understand it. This is why double opting, that means tick a box and confirm later, have also been developed to provide a stronger proof of informed consent from the user. These requirements, coupled to other initiatives such as Terms of Service Didn't Read, known as TOSGR, has changed the consent collection mode. Instead of having multiple pages very detailed and largely non-understandable, which led de facto to approve without reading, templates structures used by large families of purposes allows to accept or refuse groups of purposes. Nevertheless, this may be not enough to ensure privacy, as information on data processes and their other legal obligations such as the Cloud Act are often missing. This leads to a risk against sovereignty. Another important obligation related to the fair, lawful and transparent data processing is the development of an efficient data protection and security. As data controllers are accountable for the data processing, they are also accountable regarding the way data are protected. This means that setting an efficient data security policy is mandatory. including clear and consistent risks assessment and efficient countermeasure means implementation. Paying attention to the real-life consequences of any personal information disclosure, GDPR imposes a 72 hours maximum delay to notify interested parties about data tests. We can note that this delay is very, very short compared to the 240 days, representing the average delay of detecting intrusions. Lastly, a data protection officer must be appointed to manage and control the GDPR implementation. GDPR equilibrates data controllers' obligation with new rights. The potential extraterritorial protection allows transnational data transfer. This has led to specific agreements to support this extraterritorial competency counterbalancing other national, less protective regulations. Paying attention to the complexity of distributed IT processes and infrastructure, GDPR grants data controllers the right to define precisely their accountable subcontractors in order to define responsibility chains. By this way, each actor is accountable of its own actions. Of course, this can be seen as a right. I can decide that I am not accountable for my subcontractors as I cannot fully control them. But this can be also seen as an obligation. If you don't want to pay for actions of your subcontractors as done, you must specify clearly their co-responsibility chain and deploy means to show that you've done the job properly. The main rights provided to data controllers are related to the allowed purposes. First, fitting the data economy development, GDPR legitimates merchant exchanges of personal data. This is totally new. This supports new data-based business models and marketing strategies. Selling data to support targeted advertising favors prospecting and market development based on digital activities. When you use a free resource on internet, just ask you, where is the product? You must pay for a product. If you don't pay for the web service or for the web content you get, it means that you are the product. Second, GDPR legitimates data collection for statistic purpose, provided that the statistic process is not discriminatory. Moreover, it is no more necessary to collect the subject consent if the process is related to an essential interest. An essential interest is related to health, state interest, or to system security. This new right involves that data controllers must prove the essential interest of their process and log data usage to prove that the collected data are not used for any other purpose. Regarding the subject, GDPR extends the rights of the European Union Directive 95/46/CE. Of course, any subject can get access to any data related to him or to her, whether the data was explicitly given or collected automatically, with or without consent, depending on the type of purpose. This right is enforced, as subjects must be informed of any data collection, including usage identification and motivations. They must also provide clearly their consent for this data collection. An important right granted to the subject is the right to eraser. It means that non-anonymized data can be stored during a reasonable time and must be erased or achieved in an anonymized way after this period. Another right, the right to be forgotten, allows also to increase privacy. Paying attention to the way users want to manage their digital life and their associated data, of course, the right of appeal is simplified, involving a single authority in charge of propagating the appeal along the global chain. Lastly, due to the development of dematerials processes, more and more documents are stored digitally. This means that the associated data and documents are stored also digitally. This requires allowing subjects to get back their data and documents in an interoperable way. Implementing GDPR requires appointing a data protection officer in charge of advertising data controllers about GDPR constraints and checking globally the GDPR implementation. First, data controllers have to document precisely data and processes. They have to define precisely the process purpose, the data used, and the way data are processed so that they can provide the exact information to collect the informed subject consent. To improve data security and privacy, it is recommended to set a privacy by design or by redesign strategy. It consists in evaluating from the initial design steps the privacy impact of the processes. A particular attention is paid on the data security policy, identifying potential threats, vulnerabilities of the system, and setting the adapted countermeasures to mitigate risks. Based on this analysis, processes can be redesigned, integrating the highest data security and privacy requirements. We must note that data controllers may have to demonstrate the compliance with GDPR, logging data accesses and usages, identifying clearly the processes using them. Managing data security requires integrating human-related risks that may lead to intrusion in the system. So, focusing on legal aspects, data controllers must define precisely contracts with their subcontractors so that clear responsibilities can be identified, limiting appeal risks. GDPR constrains process organization. It may limit data usage and consequently, it may impact some business models. So, implementing GDPR is not only a matter of appointing a data protection officer. It requires the involvement of the corporate governance, including top management. Business departments and IT department must also be involved in order to precise exactly the requested data and process purposes and even redesign processes to fit GDPR implementation. A particular involvement of the Information System Security Officer is needed in order to refine and precise the data security policy. We must also improve the security processes in order to track and report more efficiently potential attacks, intrusion, and data theft, and we have also to improve the internal processes on data access control to allow only accesses and usages fitting the consents provided by the subjects. This must be done in coordination with the data protection officer, who is responsible of managing the global protection consistency related to the GDPR implementation. This means that implementing GDPR in an organization is not so simple. Dedicated surveys propose best practices for the different groups of actors regarding processes, protection, and security objectives. They also include the way security processes can be designed and implemented, or they can provide a legal framework to cope with GDPR requirements. The implementation of GDPR implies a significant change in data management habits. Every action involving personal data must be logged so that data usage can be tracked and proven. It is necessary to set up awareness actions for users to explain the changes induced on the processes to enable them to improve their information technology hygiene, to avoid undue access or intrusions. This will also ensure that all actions are logged. Planning regular audit controls are also necessary to ensure that all security and data protection processes are implemented efficiently, and this will also improve data protection. And don't forget, in such audit activities, tests for the phishing activity. Even if people know that phishing may occur, the results may be surprising. So, after introducing GDPR, let's now pay attention on the way GDPR can be implemented in blockchain systems. To this end, we will first focus on blockchain key concepts and the way they can match or not GDPR requirements before showing how GDPR key requirements can be implemented. As we have just seen, GDPR implementation relies on key role identification, such as data controllers and data processors who store and consume personal data, and data subject, the natural person to whom data are related to. Under the responsibility of the data controller, using personal data involves defining precisely the process purpose to ensure a fair, lawful and transparent data processing, while subjects are allowed to get access, modify and delete their personal data. As a technologic object, blockchain systems can be seen as a neutral system, providing an immutable and safe storage of blocks storing peer-to-peer transactions. It means that there's only one process purpose, the immutable storage, and that no change is allowed, which can be seen as opposed to data updating and data erasure requirements. Focusing on the blockchain ecosystem, the variety of roles, validators, developers, users, investors, as we've seen in the blockchain ecosystem lecture, make difficult the identification of the responsibility chain, as all processes are heavily distributed. Moreover, the user pseudo-anonymity contravenes the accountability principle of the GDPR. So, implementing GDPR in blockchain systems requires analyzing the way key principles can be deployed in such distributed systems. The protection of data provided by the GDPR is based both on the identification of the objectives of the processes consuming this data and on the effective access to this data. A blockchain-based system can be seen as a simple tool for different uses. In this context, the objectives of the processes are rather related to the application services using the blockchain, while the effective access control is more related to the responsibility of the blockchain system. The definition of access control in traditional computer systems is based on elementary services called CRUD for create, read, update, and delete. Update means that you are going to read to get the data and then write a new value replacing the previous one. At the blockchain store's block, we can use this elementary service. Not so sure. Of course, a block can be created and read. This is retrieved. But the immutability property of the blockchain involves that blocks cannot be updated nor deleted. This is a major problem regarding GDPR implementation, as subjects are allowed to modify and erase their data and may also be forgotten. This questions first on what can be stored in the blockchain. Should GDPR implementation lead to never store any personal information in a blockchain and, as a consequence, make blockchain support unusable for classes of applications requiring a safe and immutable storage of personal data? How can a blockchain fulfill the data creation, access, update, and erasure requirements involved by GDPR implementation? In fact, elementary access control services must be redefined to fit blockchain systems' characteristics. As said previously, a block, including a transaction, can be created and retrieved, allowing to read its content. Considering the way the update and deletion functions can be implemented, an adaptation is required as blocks are chained, and changing the content of a block impacts the full chain consistency. To cope with the data updating requirement, a solution may consist in appending a new transaction block with updated content. By this way, the blockchain may be used as an immutable storage of logged data. This means that the blockchain contains all the different values of this data. Focusing now on the data erasure requirement, we can note that the digital data is deleted when it cannot be accessed anymore. This means that its value cannot be used in any further computation. Data deletion does not mean that the system physically destroys or thrashes the data, simply that the data record is free and can be burnt to store a new digital data. By analogy with this analysis, any encrypted data for which encryption-decryption keys are lost becomes unusable and can therefore be assimilated to destroyed data. Implementing data erasure in a blockchain is then possible for encrypted data by setting a burn operation, deleting the encryption-decryption keys associated to this data. So, turning crude elementary services into CRAB, creation, retrieve, append, and burn services, makes possible the GDPR implementation for blockchain-based systems, provided that the data records stored in the blockchain are encrypted with independent keys. Other key requirements of the GDPR are, on one hand, the data subjects and data controllers authentication, and on the other hand, the protection of the digital activity tracking. These two requirements may be opposed to blockchain system organization. First, blockchain users are identified by the key they own. This is not related to their real identity. Second, all transactions are related to blockchain activities. These transactions are stored immutably. This means that blockchain activities are immutably tracked. So it seems that blockchain contravene these two requirements. Blockchain are known as anonymity-preserving systems as they use a pseudo-identity. Users can create and retrieve a transaction according to the associated key, something they own, not something they are. Let's first consider that the user storing the data in a blockchain is the subject. It means that it is the person to which the data is related to. It means that the exact subject authentication depends on the way the subject gets and manages these associated keys, depending on the wallet manager used by the subject. We can note that when encrypted data are stored in a blockchain, the subject storing the data in the blockchain can decide who can get access to the data retrieval function by sharing or not the requested decryption key. When a subject uses the same key to sign different transactions, he may be re-identified, and this leads to a privacy risk when different sources mixing these encrypted data are used. When a blockchain is used as a certified and immutable storage mean, the blockchain user may also be an external process storing a subject's personal information. In such case, the blockchain user is associated to the process for which the associated data controller is accountable. It means that the blockchain user stores, retrieves, appends, burns transactions in the blockchain on behalf of the real subject. This involves that the blockchain can store immutably data creation, data append, and data burn actions from the data controller, who is then in charge of managing properly data encryption keys for the data user. Paying attention to the blockchain activity tracking, this risk is related to the transaction retrieval. It may be possible to browse blockchain systems, extract transactions associated to a given pseudo-identity, and make cross-sourced data privacy attacks. This is heavily coupled to the way users manage their own wallets and their cryptographic keys. The blockchain ecosystem, defined in Lecture 3, can be a strong base to identify the different roles: miners and block validators, blockchain developers, blockchain service or application layer members, blockchain investors, blockchain users. What is the link of these blockchain ecosystem roles with the rules defined in GDPR? Miners and block validators ought to be neutral regarding the data. They do not pay attention to the block context semantically, they just use it for cryptographic computations. As such, they can be seen as GDPR data processes. Blockchain developers provide the technical means to support the blockchain internal processes. These blockchain processes are also neutral. They do not depend on the meaning of the content of the transactions or the blocks they manipulate. As these processes do not consume personal data, developers are not aware of data usages, so they are not involved in key roles for the GDPR implementation. Blockchain service or application layers members are actors who use the blockchain system for a given business purpose. As such, they are aware of the purpose of the process using personal data. This means that they may be associated to data controllers and take a part in the accountability chain. Blockchain investors can also take part in the blockchain system governance. Investors can also be involved while defining process purpose. Nevertheless, this course grant purpose will only guide service or application layer members or process developers. This is why investors are not seen as data controllers. Regarding blockchain users, as we just said, the blockchain user is the entity storing, retrieving transactions in a blockchain. When the blockchain is designed as a technical component of an information system, the blockchain user is associated to the process that may store personal data in the blockchain, acting on behalf of the data subject. In such case, the user can be considered as a data controller from the blockchain interface point of view. As far as end users are concerned, they can cope with the subject and data controllers roles, as they can store data related to them and decide freely to use the blockchain for a given purpose. This last case involves a key question. Can we identify if they got the necessary knowledge of blockchain characteristics and risks to decide freely to use it? Not so obvious. Data controller is a key role in GDPR implementation, as it is the entity accountable of the fair, transparent, and lawful personal data processing. For private and permission blockchain systems, there's a clear identification of blockchain actors of their role. The blockchain usage purpose is also well defined. This makes possible the clear identification of data controllers, as responsibilities are well defined for each consortium member. It is also possible to consider blockchain data controllers as subcontractors acting on behalf of business processes related to data controllers. Regarding public blockchain, the distributed and collective data processing does not allow identifying clear responsibilities, leading to an ambiguous data controller role identification. Blockchain can be considered as a global process where end users are responsible for deciding which information is stored in the blockchain, acting as kind of data controllers. This is why data controller role is still under debate. Let's now consider the GDPR key rights. Blockchain stores blocks in a distributed way. This increases data availability, but also data security, as different copies of the ledger may be hacked. This makes harder the necessary data security control. It may make more complex to respect the 72 hours notification delay, as intrusion detection is more complex. A last problem related to the blockchain distribution resides on the extraterritoriality, mostly for public blockchains. In fact, copies of the blockchain can be stored worldwide under different legal frameworks, making harder the real control on transnational data transfers when several copies are dispatched. Whereas the blockchain distribution can be seen as a braking force regarding GDPR adoption, on the contrary, the blockchain storage can favor transparency and data portability rights. As blocks are stored immutably, retrieval functions can be used to get access and extract relevant personal data stored in the blockchain. Of course, this limits the data updating and data erasure rights unless CRAB services are set, as we've just seen: create, retrieve, append a new transaction, and burn a key. To sum up, implementing GDPR in blockchain systems challenges for identifying clearly data controllers. It also constrains data due to the blockchain immutability property. Storing data in a blockchain means that data can be retrieved. This scope GDPR constraints for anonymous or immutable and public interest data. For example, a diploma certification may be considered as a public interest data. For more sensitive data or the implementation of erasure right, this requires storing only encrypted data so that CRAB services can be deployed. So, it sounds possible to implement GDPR in blockchain systems. Nevertheless, blockchain is still an immature technology with potentially new usages. This means that key questions are still under debate and that blockchain must be considered as a technical tool, among others. Implementing GDPR-compliant blockchain systems requires integrating the blockchain in the complete data processing architecture, defining clearly and precisely blockchain usage purposes. Similar to other components of an information system, personal data involved in a blockchain must be minimized and a particular attention must be paid on the data pre-protection. So, when it is impossible to use anonymized data, we need to obfuscate data to provide a minimum privacy protection, while encrypted data can be used to manage properly CRAB services and increase privacy. But keep in mind that if the distributed organization of the blockchain increases data availability, it may also be seen as a security vulnerability or security threats, as copies of the blockchain may be dispatched without much control. As GDPR requires a safe logging of the different consents and actions, blockchain technology can also be seen as a convenient support to monitor consent collection and usages thanks to the immutable and safe storage feature it provides. In this last part, we introduce some recent research works dealing with this opportunity. GDPR empowers users with their personal data and privacy management by setting new obligations for the organizations and processes consuming or storing personal data. Processing personal data in a fair and transparent mode involved by GDPR requires three different things. First, natural persons to whom the data are related must be informed about the processes and the storage. Second, processes and organizations consuming or storing personal data have to collect the natural person consent for this data processing and storage. Third, these organizations and processes must also monitor the way these personal data are involved in the running processes to prove this fair and transparent mode. The data controller is in charge of a process consuming personal data. As such, he is responsible of the fair, transparent, and lawful data usages. This means that the data controller may have to prove that data are collected and processed according to the collected consents. This leads to two key challenges: proving that an informed consent was collected and that personal data are accessed and processed only according to the predefined and agreed purposes. To meet these challenges requirements, a safe and immutable log storage feature is required, leading to study how blockchain can be used to provide the technical means to improve GDPR implementation. First, let's consider how blockchain can be used to manage consents. Broadly speaking, a consent may be modeled as a set of access rules. Each rule is represented as a tuple describing the subject, who will be granted or not a usage right, the object, that is the set of data of which the usage right is provided, the target usage, and conditions such as time, validity, decision part, grant or deny the right. In this slide, you can see an example picked from the ontology-based right expression language, showing that an access right rule can be modeled in a similar way. The key point consists in specifying GDPR-adapted usages, paying attention to the access operation and to the business process purpose to legitimate or not the personal data usage. To define the process purpose, we can reuse works inspired by the usage-based access control. For example, we can pick the UCAN ABC model defined in 2011, and you can find the reference in the lecture notes. This module relies on a usage ontology to define rights that are associated with basic usage operations, namely the CRUD, create, read, update, and delete operations. Subjects will get a usage rights. Objects define the asset on which the usage right is granted. Obligations are associated to protection means, and restrictions are associated to time or environment constraints. We have proposed to expand this ontology to integrate more complex data-related operations to define more precisely the way data are processed, exchanged, replicated, and stored. We have also proposed to integrate organizational knowledge to define the subject, which can be a user, a group, or an organizational entity. Business knowledge must also be integrated to define more precisely the usage context, specifying a process motivation, the process purpose, the business scope related to a particular business area. By this way, we can capture a finer-grained description of the processes and the usages, and this will help the end user, the people owning the personal data, to decide about the risks of sharing the data with this particular organization for this dedicated purpose. In order to prove that a consent has been collected, a blockchain-based system can be used. In such case, a consent is modeled as a peer-to-peer transaction linking the subject, the natural person to whom the data is related, and the data controller, the entity responsible at the GDPR compliance management for a given set of processes. We can note that for this consent storage, the subject is really the person to whom the data is related, and not the entity getting the grant to use the data. This time-stamped transaction can be stored immutably in a blockchain so that both subject and data controller can refer to it to prove what has been granted or not. Logging different time-stamped consents is also possible so that the subject can change its privacy requirements and the data controller can extract the exact time-stamped consent to allow or not the personal data processing. Getting several time-stamped consents is also useful for the data controller, as he may provide the proof that at a given time the processes were achieved according to the current consent, even if after this processes the user has changed his mind about the consent. As a consent may be considered as a sensitive data, systems often store the encrypted consent and/or its hash so that the blockchain records supports for the consent approval proof. Blockchain can also be used to prove that data are used according to the approved consent. Different works have used smart contracts to implement access or usage rights. This provides an efficient support, allowing users to retrieve the smart contract derived from a given consent in order to check the precise usage rule and usage condition. In fact, the smart contract is used as a kind of Kerberos authorization system. When a smart contract is launched, it provides a token to the data consumer to prove that the usage operation can occur while logging the access operation. Despite its interest, such smart contract-based access control remains complex, and the main risk is related to the way blockchain users are identified. If a cryptographic key is hacked, access right tokens can be transferred to unauthorized users. To overcome this problem and ensure that sensitive personal data cannot be accessed without authorization, other works propose to store an encrypted personal data using smart contract to transfer the necessary keys to allowed processes. By integrating several encryption processes, this is quite similar to the Internet Key Exchange Protocol. This architecture leads to complex computations, but there are reduced risks that the sensitive data can be used by unauthorized actors. So, thanks to its immutability characteristics, blockchain systems can be seen as an efficient technical tool to support GDPR implementation. Different application services are defined to this end, including personal information management systems, or PIMS, allowing natural persons to manage consistently their own personal information system. The consent manager can be also widely used by data controllers to prove that their usage fits the provided consents, and even access control systems may be used to log usage or access operations. Most of these systems are based on private and permission systems, easier to manage and control. This also minimizes the personal data they store so that no extra GDPR constraints are needed. As we have seen in this lecture, GDPR constrains blockchain implementation, and at the same time, GDPR implementation can take advantage of the blockchain property. Now, it's time to conclude. GDPR has been adopted by the European Union in 2016 and has been applied since 2018. It provides a legal framework to improve privacy for European Union citizens. It defines clearly new rights for data consumers, such as the authorization of statistic process or transnational data exchange, but these new rights are counterbalanced with obligations such as strict and informed consent collection or logging usage and data accesses. This means that usages must be developed in a fair and transparent mode. Natural persons owning their own information are also empowered to manage their own information system privacy policy. This data protection regulation has initiated an extraterritorial control on privacy for European citizens. This is totally new. Its key principles, fitting the digital transformation involving more and more exchange of personal data, have been reused by other countries to set their own extraterritorial data protection regulation. So even if GDPR is limited to personal data of European citizens, it's more or less similar for lots of countries in the world, and regulations are still under development. Despite its interest, GDPR protection is limited by the end user themselves, as they may non-consistently consent to share personal information with various and sometimes unknown actors. Often, they also don't pay attention to the process purposes. So, key questions are related to data disclosure, as they may be opposed to data controllers. Finding the root cause of data disclosure is not obvious, and data consumers, I mean the service providers consuming the data, must prove that they are not the cause of the data leaks. To this end, of course, blockchain technology can provide its immutable storage proof means to store the consents they collect and the access they grant to the data. We can note that GDPR was defined as a first step regarding the data economy protection. The new European Union Data Governance Act, approved in 2022, is designed for the different kinds of data. So GDPR is a particular part of this regulation, and other parts of data, other kinds of data, will be protected as well by similar principles and rules. Due to its intrinsic distributed organization, blockchain can hardly cope with the GDPR requirements, mostly regarding the identification of data controllers and data subjects. The definition of the new CRAB elementary data manipulation services for create, retrieve, append, and burn allows fetching the data access, logged data updating, and even data erasure for encrypted data. So, data in a blockchain must be encrypted. This is a sine qua non condition to cope with GDPR. Also, due to its safe and immutable storage ability, blockchain can be used worthily to store timestamp consents or log data accesses, as I've said previously. This can be done thanks to smart contracts. By this way, data controllers can manage efficiently proofs of their fair, transparent, and lawful usage of personal data. This lecture has been prepared using the following resources. Online resources have been checked by the fall 2022. You can also use these resources, links, and papers to get more precise knowledge on GDPR, on how to manage GDPR with blockchains. You can note that this is a really evolving area, so you can use the key part of the links just to get informed of the different new developments. Thanks for joining the Erasmus Plus CHAISE project Module 2, Lecture 6 on blockchain and GDPR. Let's get in touch using our social media and website.